Okay, in this question we have two parts. Let's look at part one. A die is rolled 360 times. By now you know what is a die. You know, it's the die that has 6 faces. It's the cube with 6 faces, and each has numbers from 1 to 6. Okay, so a die is this one. It's rolled 360 times. So this means we have n trials. The n trials are 360, the number of trials here. Then find the mean, variance, and standard deviation of, let's see, of what? Of the number of 4s that will be rolled. So for us in this case, read again, the number of 4s that will be rolled. That is our x. So, I mean, x is always the number of successes in the trial. So we need to just say that success in this trial, success is the same as saying, means that getting a 4, getting the die to land on this face, the face that has 4. This means, so therefore we can write here, it's better to actually do this before you see the formulas. So you can say here, therefore, n, the number of trials, is 360. The probability of success, which we call little p, it's the probability of success. Success means is the probability of getting a 4. This is 1 out of 6 possibilities. And immediately from this, you know that q, which is the probability of failure, is always 1 minus p. And so if you take 1 minus 1 over 6, you'll get 5 over 6. So let me just highlight what we found. N is this, P is this, and Q is this. Okay, so keep these 3 numbers in mind. So actually, what we can do is we can now jump to solve question 1 on the second page, remembering these 3 numbers. So the formulas are here. Because we have a binomial distribution in this case, binomial distribution is when you have success or failure. So you have 2 possible outcomes, and the probability of success remains the same for all the trials. The trials are independent of each other. If you roll the die 360 times, the first roll is not affecting the second or the third or the 360th. So they are independent, so that's why it's a binomial. But you can immediately see it's binomial just by reading the question. So n is 360 trials. We remember that p, the probability of success, which is getting a 4, was 1 out of 6. And q, which is 1 minus p. Again, I like to always remind you, in binomial distributions, q is 1 minus p, and it's 5 out of 6. This is how you find q. So therefore, let's compute them. Okay, so let us give the mean blue color, the variance green color, and the standard deviation this orange color. So let's start. Therefore, the mean mu is equal to n times p, and so it will be 360 times 1 over 6. So we have all of the information needed here, and this will give you 60. So remember also that we call it the expected value. This the mean for a discrete probability distribution also is the expected value. That's another name for it. So in other words, you can actually, it makes sense that we got that the mean is 60, because if you roll a die 360 times, it makes sense that you expect to get 60 times the 4s, that it will land on a 4, because there are 6 possibilities and 4 is one of them. So it's as equally likely as the other faces of the die. So, but anyways, you're not asked to do to interpret. I'm just helping you understand this question better. Now we can say also, therefore, the variance, now the green one, sigma square, which we call the variance. This is n times p times q, which will be 360 times 1 over 6 times 5 over 6. And if you do this calculation, you'll get exactly 50. This will be your variance. And now the best one is the standard deviation, because it's the easiest one to do. Sigma, it's just the square root of the variance. So it's the square root of n times p times q, which we have just calculated to be 50, so square root of 50. And square root of 50 gives you approximately, to 3 digits, 7.071. Or if you want it to 2 digits, you can say 7.07 if it's only to 2 digits, okay? Depending on the question. Anyways, so now we are done with the first part of this question. The second part, which is a little more interesting, because you need to read something. A certain large manufacturing facility, so now I'm in question 2, produces, let's see how many, oh, that's a big number, produces 16,000 parts each week. The manager of the facility estimates that's about, now he found that 3.5% of the parts they make are defective. Okay, so the important things that you need to know, I highlighted them. Now again, in this question, we need to find the mean, the variance, and the standard deviation for, and let's read carefully now, for what? For the number of defective parts made each week. Okay, so this means for us in this experiment, it's of course a binomial experiment, that defective part, if it's a defective part, it's a success for our experiment, because we want to see the number of defective parts. So I would write it here, that success for this experiment, success is the same as getting a defective part, or getting defective parts. So now, how many trials do we have? We have a lot. Each week they produce 16,000, so n is 16,000. The probability of success, little p, in our experiment, remember success is getting a defective part, is written for you here. The manager found that it's 3.5%, which is, you can write it as a decimal, and you must write it as a decimal for this question, 0.035. And last but not least is Q. Q is the probability of failure, which is 1 minus the probability of success, P, which is, of course, P was what? What's 0.035. And so Q will be exactly 0.965. Let me just highlight them again. The number of trials, 16,000. The probability of success is this number here. And the probability of failure is this number here. So we take these three numbers, and they will give us the mean, the variance, and the standard deviation. So I'm going to just copy them on the last page where we have the question. So here n is 16,000. We found that p for this is 0.035, and q, which is 1 minus p, is equal to 0.965. Okay, and let's do first. Let me highlight them. Okay, those three. Put them each in a bubble, a small bubble like this, and let's solve the question. So we will do it again in colors. Let's make the mean in blue, the variance in green, and the standard deviation in orange. Okay, so therefore, once you have the n, the p, and the q, you can find the mean, or the expected value is equal to n times p, which is 16,000 times 0.035, and if you compute it on your calculator, you should get exactly 560. That should be the mean for this question. Now, the standard, the variance, sigma square, now we are doing the variance, sigma square is n times p times q. And this will be 16,000 times p, which is 0.035, times q, which is 0.965. And if you compute this, you'd get exactly 540.4 on your calculator. Okay, and the last and easiest one, I forgot to say therefore here for this variance, and so therefore also the standard deviation sigma is the square root of the variance, which is n times p times q, and we computed it already, so it's the square root of 540.4, which is approximately 23.247. Or if you wanted to do two digits, you can say it's approximately 23.25. If you want to two digits, it depends on what you're asked to do. So you see, in binomial distributions, the formulas are very simple. So just remember also that if you know how to find the mean, then the variance is only multiply the mean by q, because it's n times p times q. And then the standard deviation is the square root of the variance. We all know it already, so there is no need to memorize anything here. Just know the mean, n times p, and then remember that the variance will be whatever you found for the mean, n times p, but just multiply by q to get it complete. And then the standard deviation is the square root of the variance. And I hope that by now you are more comfortable with solving questions about the binomial distribution. This will end this question and its solution.